Actually, let's make a second video for this. So let's finish this up because I kind of rushed through this. So we had our friends Susan and Lisa, and we wanted to line them up, and we had 10 factorial ways and 10 factorial ways we add them together to get that. Now, another way to look at it is to say, look, let's look at Susan and Lisa first. How many ways can I line Susan and Lisa up? Well, there are 2 factorial ways to line Susan and Lisa. Okay, I can go Susan then Lisa, Lisa then Susan. And then I ask myself, what's left? 10 friends. How many ways can they line up? 10 factorial ways. So if you multiply 2 times 10 factorial, you get the same answer as you get over here. Okay, so this is 10 factorial plus 10 factorial, which is the same as 2 factorial times 10 factorial, right? Because what's 2 factorial? 2. So 2 times 10 factorial, 2 times 10 factorial. Kind of neat. Different ways to look at things. There's no right or wrong. Well, there is right or wrong. There's no right or wrong way to look at these questions, but there are right or wrong answers. I'm going to make a word, again, and we talked about words, and words that don't have to make sense. So, for example, a 4-letter word of LLST is a word. I'm doing air quotes right now in the world of math. Okay, so letters can't be repeated. I want to know how many different ways I can choose make a word, and that is this question here, or it's represented this way. There are 26 letters. Remember that, and I'm going to choose 4 of them and put them in order. Okay, so I'm not repeating. So what that turns out to be when you clean things up is 26 times 25 times 24 times 23, which was originally 26 factorial. So this is 26 factorial over, and 26 subtract 4 is 22 factorial, like this. And you cancel out the lower 22 of these to end up with this. Letters can be repeated, so a different question, okay? That's not our normal question. So let's ask ourselves this. How many options do you have for the first letter in the word? 26. Now, I can repeat myself. So how many options do I have for the next word? 26. And how many options do I have for the next word? Next letter. 26. And the next letter? 26. Okay, so that's 26 times 26 times 26 times 26, which could also be represented as 26 to the 4. Okay, different questions. How do you know which one's which? Read the question. Okay, letters can't be repeated, but A must be the first letter. So I'm making a word. It has to start with A. So I start with A. Now, if you say to yourself, why are we doing this? You talk about programming and computer language, or you're talking about putting things in order, or that sort of thing. You're going to come down to situations where you might have to represent things with words. And again, air quoting the words. Okay. So here we have a question where every single word has to start with an A, and then I have 3 other letters. Okay. So letters can't be repeated, and A must be the first letter. That means I can't have another A, right? So I have 25 options for this, okay? 24 options for this, and 23 options for this, okay? So 25 times 24 times 23. Or ask yourself this. How many letters are you ordering after you put the A in place? Okay, so what goes here? How many letters are there? There's 25. And how many am I putting in order? 3, okay? That's 25 divided by factorial, so this would be 25 factorial over 22 factorial, which turns out to be the same as 25 times 24 times 23. Okay, how many options do you have for this? 1. So if you really want to be careful, you could say it's 1 times that, but you get the same answer. Letters can't be repeated, and A must be one of the letters anywhere. Great question. Thanks. Okay, so I have 4 spots here, and I have to get 4 different letters, and A is one of them. Give you a couple seconds to think about that. You might want to pause it. Okay. One way to approach this question is this. Where does the A go? I don't know. Does it go here? Maybe. Does it go here? Maybe. Does it go here? Maybe. Does it go here? Yeah, I don't know. So how many options do I have for the A? 4. Okay. So I have 4 different options for the A. So where does it go? One of these spots. Choose one. I chose one. Okay. Now it's gone. That's out here. Now I have 3 spots that have to be filled by 1 of 25 letters, or 3 of 25 letters. Sorry. So now it's 4 times 25 P3. Because I have 25 options for this, 24 options for this, 23 options for this. Another way to look at that question is to say, let's break it down into 4 similar questions. Okay, so if you didn't like that, well, maybe like this. We had this situation, A blank blank blank. That was this one over here. And we said that there were 25 times 24 times, so we had this as our answer for the number of options for ways that this could be set up. Now, if I'm not going to put A first, what happens if I put A second? Well, I still have the same situation. So I have this plus this again. Now, what about scenario number 3, where A is third? Exact same thing. I'm adding that again. How about scenario number 4, where A is last? Exact same thing again. Okay, so how many of these do I have? 4 of these. That's 4 times this, 25, 3. So it's 4 times one of these here. Exact same thing. Is one a better way to look at it than the other? No, they're 2 great ways to look at the same question. Okay, let's keep going here. 4 people are, this is a classic seating problem. 4 people out for dinner and sit on a bench. So the bench meaning that we're like this, okay, in order. How many ways can they be seated? Simple question, 4 factorial. If 4 people out for dinner sitting at a round table, how many ways can they be seated? Okay, so this is a great question, and it turns out, so the difference between a round table and a square table, okay, if I was at a square table and I said, all the seats are different, so we have a red chair, a blue chair, a green chair, and a yellow chair, something like that, right? And we look at this sort of thing here, and we have these different people, and it's different if I have, forget this for a second. Let's say I have Tim, Mary, Susan, and Lisa. Okay. Sorry, I messed that up. Let me start this again. Okay. So the difference between this bench table and the bench table and the round table or the square table. Okay. It doesn't matter about the shape of the table. Okay. What this is saying is this is different if I go A, B, C, and D, right? Everything's different. The guy beside, I'm here, I'm at the end, B's beside me here. That's a lot different than being here. Like A and B could be here side by side, right? But that's not the same scenario as this, okay? Right? So that's completely different than this. So if I go, well, it's still A, B, C in order, but D's over here, that's not the same. If you sat like this or you sat like that, it'd be the same. It's not the same thing. Now, we're not going to talk about specific chairs. I messed it up. I shouldn't have said it that way. What I'm saying is if you're at a round table like this, if I sit here, if I put you in order like this, A, B, C, D, and you don't care about who's near the window or whatever, but you're asking yourself this, who are you sitting beside and who are you sitting across? That's the same, this guy here. So if you go, well, it's 4 factorial ways to seat this, you're almost right. But what we're saying here is if I seat people like this and I happen to seat them like this, okay? So again, here's the window, but we're not worried about the window. We're worried about relationship, like who we're sitting beside. A is still across from C here. B is on my left, if you look at it that way, and D is on my right. Here, B is on my left, D is on my right, C is across from here, okay? So there's that, right? And then you look again, and if I could do this again here, right? Like that, and then also like this, okay? All these are the same. Okay, so it's a little bit different than A, B, C, D. It's a little bit different than this. Okay, and what happens is there's kind of repetition. So if we work this out and we figured out all the different relationships, it's not based on who sits where, it's who sits relative to each other. So let's look at this. We have A. Let's look at this one here. A, B, C, and D. Okay, so there's one scenario. The next scenario is A is across from, not C, but A, well, actually, let's look at this one. A is across from C still, but B is on my right, and D is on my left, on A's left. Okay, so this guy is different than this guy, not the same. They're across from each other, but these people are in different ways. So this guy's a lefty or something. This guy's, D is on the left now, okay? That's it for A across from C, okay? Let's look at the next scenario. A across from, I don't know, B. It doesn't matter. We're going to do all of them. A is across from B. I can put C on A's left and D on the right. I can also say A is across from B with C here and D's here. Okay? And I'm going to go one last one. A is across from what's left, D, and B here and C here. A across from D, C here and B here. And how many different ways can you do this? 1, 2, 3, 4, 5, 6. Okay? The neat thing about this, if you go, wow, that's kind of nuts. The neat thing is when you're putting people in order, but not in a straight order. So if it's in a circle, what we call a circle, really, okay? Now, the table itself doesn't have to be a circle, but if order matters, but there's no start and finish, right? Like, where's the start of this table? I don't know. Is it here? Is it here, right? It's when order matters, but there's no start or finish. So classic example is when you put people in a circle. There happen to be, in this case, 6, which is 3 factorial different ways to do this. So in general, if you put n people in line, you have n factorial ways to line them up. And if you put them in a circle or no end, you have n minus 1 factorial ways. Okay. So example, we had your 8 friends. Your 8 friends are at the movie theaters. There's 8 factorial ways to line up you and your 8 friends. Okay. But if the question was you're at a big table, okay, and now it doesn't really matter exactly where's the start and where's the end, you'll have 7 factorial ways to line those people. Kind of neat. Okay. So we'll talk more about this in class. I may have confused in this last one, but in general, If you're talking about anything in a circle, it's 1 less than the number of things factorial. Okay, hope that made sense.